There are a number of ways to find out how many solutions a system of equations has algebraically. And certainly after watching the previous video of solving how many solutions a system of equations has graphically, you'll have noticed that when the slopes are the same, and when the slopes are the same, that you have either infinitely many solutions or no solutions, and when the slopes are different, you have exactly one solution. Certainly, you could even use elimination or, if possible, substitution to try to solve for one solution if there was a solution. But if there isn't a solution after doing that, you've no way certainly of telling exactly how many solutions there are, if there are any at all. So um, possibly the easiest way to figure this out is by going by that table that I introduced to you in the last video. If what we do is we draw ourselves a table, and the first thing we're looking for here is we're looking for the number of solutions based on, so the number of solutions based on the slope m and the y-intercept b. Okay, so we found before that when the slopes were different, there was one solution exactly, right? And that made it pretty straightforward. We didn't have to worry about what b was. It was the slope being different was enough for the two lines to intersect. Okay, so the other situations were when the slope is the same, right? Okay, so we have two situations. We have zero solutions and we have infinitely many solutions, right? And when the slope is the same and the y-intercept is also the same, those are two lines that are intersecting at every single point, so they have infinite solutions. But if the y-intercept is different, then they're parallel lines, they don't intersect. Okay, so these are the things, these are what we're looking for, right? So all we need to find out is we just need to find out what the slope and the y-intercept is. So you'll have equations either in standard form like this or in slope-intercept form, and you'll be able to find out what the slope and the y-intercept is. So let's take a quick look. We know that our slope, easiest one to look at is look for the slope first, because if it's different, you don't have to go any further. So the slope here, the slope m is, of course, the inverse of the first term, the term with the x, so that's negative 10 over the y term, which is 3, so negative 10 over 3. Let's look at this one here. The slope for this one here is the inverse, again, of the x term, which is in this case positive 20, over the second term, which is negative 6. Now, when we simplify this, we see that we have negative 10 over 3. So we know that the slopes are the same, right? So we're in this bracket right here, okay? The slopes are indeed the same. We've got to find out whether the y-intercept is different or not. And we can almost see here what might happen, because we've got some very similar numbers going on here. With this one here, our y-intercept b is 9 over 3. So the third term 9 divided by the y term 3, giving us 3, so a y-intercept of 3. This one here, we have negative 18 over negative 6, which when we simplify this, we find 6 goes into 18 3 times. Negative divided by a negative is a positive. So we actually have the same y-intercept as well. So we're looking right here, we're looking at the same slope, same y-intercept is going to give us infinitely many solutions. Okay, let's look at a couple more. This one here, straightforward. We've actually got our slope-intercept right here. Our slope m is negative 3, and our y-intercept b is negative 2. Right. For this one here, all we have to do actually to get this into slope-intercept form is to divide everywhere by 4. It's almost in slope-intercept form, but it's not quite. So now it is. Now when we cancel that out and simplify, we'll get whatever we want. So whatever we're looking for. So our slope, negative 12 over 4, is of course negative 3. And our y-intercept, negative 8 over 4, is also negative 2. So we can see here slope same, y-intercept same, so there are no solutions. There are infinitely many solutions because these two lines are exactly the same line. So again, slope -2, y-intercept of 4. This one here, again, we're same technique we used in the last question. We're just going to divide everywhere by 7, and we get here the slope is -14/2, which is -2, and the y-intercept is 28/7, which is also 4, and again we have infinitely many solutions. Okay, let's look at one more. This one here, we've got standard form. All right, so we've got a little bit of work to do to get our slope and our y-intercept. We have the slope here is given by, again, the inverse of the first term, so that's -11 over the second term, which is -6. Simplifying that just gives us 11/6 because negative divided by a negative is a positive. And our y-intercept, well, we won't look at that yet. We're going to look at just the slopes for a second. If we need to go into y-intercept, we'll go into y-intercept. So this slope here, the inverse of the first term here, so that's going to be +4, just change the sign on it, over -6. And immediately we see here this is -2/3, which is not the same as 11/6. So we know we don't even have to go into the y-intercept here, which would be the 5/6 and 13/6. We don't have to go into the y-intercept because the slopes are different, telling us there's exactly one solution. Just to recap real quick, the number of solutions, which would be 1, 0, or infinite, is given by the slope. And if the slopes are different, we've got one solution. And if the slopes are the same, then what we're looking at, then we start to look at this y-intercept, and we can see here that if the y-intercept is different, we get 0 solutions, and if it's the same, we get infinitely many solutions. So this is a pretty useful chart here, a pretty useful cheat sheet to take a note of that you can use when trying to solve these problems.